Hi, this is Dr. Ray Mao, a research fellow at Nanyang Technological University and the founder of Ray Mao Tech. I'm very happy to introduce our latest computational metaphor processing system, MetaPro Online, at the 61st ACL conference. Metaphors are special linguistic phenomenon. These linguistic creatures love to dance through our everyday conversations. Relevant statistics found that we use 6 metaphors in every single minute of speech on average, but my opening statement found that this number may be a little bit conservative. Why do we need a system for computational metaphor processing? It can be seen that current AI techniques cannot understand metaphors well. Given a metaphorical expression, the comedian convulsed the children. A pattern language model fine-tuning based sentiment classifier yields a negative sentiment polarity. A generative AI also says it's negative and gives its explanations. The AI says the word convulsed typically denotes a strong, uncontrollable movement or shaking, which is often associated with negative connotations. What we can speculate is that the AI generates a negative label for this sentence based on its understanding of the literal meaning of the metaphorical word. However, there is a difference between the real meaning and the literal meaning of a metaphor, which also creates great obstacles for AI to understand metaphors. Since human understanding metaphors often relies on cultural references and shared experiences, metaphor interpretation is subjective and culture dependent. In a different language, for example Chinese, literally translating the comedian convulsed the children as the comedian caused the children convulsions cannot lead to correct interpretation of the original English metaphor for Chinese people. But if metaphors are automatically paraphrased or explained, it can be easier for humans and machines understanding metaphors. If we paraphrase the sentence, the comedian convulsed the children as the comedian amused the children, we can see that all the aforementioned AI applications can yield correct predictions. Normally, we define the process of metaphor identification and linguistic interpretation as linguistic metaphor processing. However, metaphors are not just a linguistic phenomenon. George Lakoff and Mark Johnson believed that metaphors reflect human cognition in their book, Metaphor We Live By. Given she attacked his argument, we projected the argument concept to a word concept. George and Mark defined argument as a target concept which is constituted by the immediate subject matter. Word is a source concept in which important metaphorical reasoning takes place. If an argument is projected to the word concept, the argument is likely associated with strategies, attack, and defense behaviors that are commonly used in the war. George and Mark believed that metaphors frames our cognition because we learn abstract concepts from metaphors. Without metaphors of magic, attraction, madness, union, nurturance, love is not love. The motivation of developing MetaPro is that we aim to help linguistic learners better understand English metaphors, improve metaphor understanding in downstream AI applications, and offer an automated tool to facilitate cognitive science researchers in analyzing cognitive patterns on a large scale through concept mappings. There are 3 tasks in our MetaPro system. Task 1, metaphor identification that identifies metaphors on word level from full sentences. For example, detecting convulsed is a metaphor in the sentence, the comedian convulsed the children. Task 2, metaphor interpretation that aims to paraphrase single-word metaphors into their literal counterparts. But single-word metaphors cannot cover the whole spectrum of metaphors. We also need to explain metaphoric multi-word expressions. We did not try to paraphrase metaphoric multi-word expressions because we do not have such a dataset for learning. For example, we paraphrase convulsed in the aforementioned sentence as amused, and in the context that negotiation was a hot potato, we explain hot potato as any subject which several folks are talking about and which is frequently argued. Task 3, concept mapping, tries to abstract source and target concepts and generate concept mappings. For example, generating concept mapping, pleasure is trouble for convulsed in the context the comedian convulsed the children. Pleasure is a target concept and trouble is a source concept. The UI of MetaPro is very succinct. Users can easily input text via the left window and deliver their queries via the right button. Let's try to MetaPro the sentence "The comedian convulsed the children." MetaPro's output appears on the right side. First, under the metaphor identification tab, MetaPro identifies convulsed as a metaphor. Under the metaphor interpretation tab, the original input is paraphrased as "the comedian amused the children," which is the intended meaning of the metaphor. Next, the conceptualization tab shows how source and the target concepts are abstracted and conceptualized. For example, the target concept pleasure is conceptualized from the paraphrase amuse, and the source concept trouble is conceptualized from the original metaphor word convulse. Finally, we extract the target and source concept pairs, forming the concept mapping pleasure is trouble. MetaPro can also explain idioms and metaphorical multi-word expressions. Let's try another example. The negotiation was a hot potato, hurting both parties. In MetaPro, the metaphoric single-word expression hurting is paraphrased as upsetting. The multi-word expression hot potato is explained via a clause where a hot potato means that, and a subject which several folks are talking about and which is frequently argued. The conceptualization tab shows the result for the single-word metaphor. Feeling is ill health, but the concept mapping for hot potato is missing. We have not achieved this in the current version due to very limited learning resources for learning a model to generate abstract concept representations for multi-word expressions and sentences. The framework of MetaPro can be seen on the left, which incorporates our previous developed models in metaphor identification, interpretation, and concept mappings on the right. A metaphor identification model is first employed to identify metaphorical words in a sentence. The method was published on AAA 2021. We focus on identifying open-class metaphors because these words contain more semantic information than other parts of speech. We also use the rule-based method to identify if a metaphor is a part of a metaphoric multi-word expression. If it is a multi-word expression, it would be explained with a clause by its dictionary definition. Otherwise, a single-word metaphor would be paraphrased with its literal counterpart by using a masked word prediction method and the WordNet knowledge base. The metaphor interpretation method was published on the Journal of Information Fusion in 2022. Finally, we generate concept mappings from the identified single-word metaphors and their paraphrases based on a statistical learning method which was published on AAA 2022. We have made detailed evaluation on different modules, including automatic and human evaluation on diverse datasets. We also leveraged the MetaPro as a text preprocessing method, using its generated concept mappings and interpretation outputs for the tasks of depression detection and sentimental analysis, respectively. The bar chart shows that MetaPro can bring extra gains for diverse classifiers on these two tasks. MetaPro shows the strengths in analyzing various forms of linguistic metaphors, such as single and multi-word expressions, and encompassing both conventional and novel metaphors. It can abstract the source and target concepts from single-word metaphors. However, MetaPro cannot process extended metaphors and metaphorical inferences due to the very limited learning datasets. The applicability strengths of MetaPro are that it covers two fundamental metaphor processing tasks, such as linguistic and conceptual metaphor processing. The natural language output can be easily accessed by humans and machines. The input of MetaPro is not restricted to selected clear-cut examples or a specific domain. It can operate on real-world natural language from different domains with diverse syntactic constructions. It depends on manually developed knowledge bases such as WordNet and multi-word expression processing dictionaries. It cannot paraphrase and conceptualize multi-word expressions. We will fulfill these gaps in the future work. Finally, I would like to show some use cases of MetaPro. For example, after paraphrasing the sentence, Rio Tinto CEO Sam Walsh rejects fears over China growth demand, as Rio Tinto CEO Sam Walsh eliminates concerns over China growth demand. The incorrect predictions from VADA, LNLP, and Asia sentiment classifiers can be fixed. Concatenating the explanation of a metaphoric multi-word expression after the original input is also helpful for yielding correct predictions for the three classifiers. For the task of depression detection, we published an explainable encoder that allows users to retrieve important input elements from a prediction in Calling 2022. We used the metaphoric concept mappings as an additional input to discover common cognitive patterns of depressed Twitter user and found that level is importance is a featured concept mapping among depressed people. Such a cognition may stress them if they frequently maps an objective measure in the level concept to a subjective feeling concept like importance. These use cases show that MetaPro has huge application potentials in computational linguistics and cognitive science. Thank you.